Really wanted to go through with no technical difficulties. Boom.
Cool.
All right. So it's not like spending a couple of weeks learning LOL code only to find, I have to click on this now. Only to find out that nobody cares. So wherever you go, the principles and practices of testing is going to stick with you. So I like to break this presentation up into about two different parts. First and foremost, unit testing, followed by test-driven development, because the two are actually different things. But I feel a lot of people kind of intermix the two terminologies. It's very possible to be a very good unit tester, but being very bad at actual test-driven development. So before getting into the two types of testing, I like to introduce and define what types of testing there are, because we're going to be talking about unit testing and integration testing, and it's not always obvious what those might be. So first and foremost, I just consider a unit test as something that verifies that an isolated unit of work functions as expected. Keyword there is going to be isolated. The second test that we're going to be introducing is an integration test. And I just kind of bundled it up as anything that can't be described as a unit test. And so yeah, there's smoke tests, there's acceptance tests, UI tests, etc. But I don't want you to get into this mind of like, oh, there's so much that I have to worry about, when really all those types of tests are just forms of integration tests. Units focus on one specific area, and integration test is going to focus on multiple units. I love images like this that really just kind of really hit the point home of unit versus integration. So imagine, if you will, we have a system that has two units. It has a it has an outlet that I bet works perfectly in isolation. We have the soap dispenser, which obviously works perfectly in isolation. But when you deploy those two together, they don't work together. So what makes a good unit test? First and foremost, they have to be fast. One of the products that I work on, Exorcism, we have somewhere in the realm of 9,000 unit tests for our core product. And so even if each test were to take 1 second, you're looking at about 2 hours to run through your entire test suite. And unit tests are something that you are running at least every build, if not, if you're using live unit testing, somewhere in the round, every few keystrokes or so. So you want to have a really fast response time on each of your unit tests. They need to be isolated. Each unit test needs to be able to work on any environment that you throw at it. There should be no dependency on a file system. There should be no dependency on a database. There shouldn't be any sort of setup time in terms of like, hey, GSS needs, or customer care needs to set up this test for me, and then the next day on test it's gone because it refreshed. Make sure that each test has full control over itself. Tests need to be repeatable, and this means that every time that you hit the test run, you should know exactly what the result is going to be execution after execution without assuming you didn't change any of the production code. And this is kind of a problem with integration type tests, because you think of running like a DML statement against our dev database. If you change that data, your test isn't more than likely isn't going to be repeatable. You'll have to do some sort of rollback to get that data into a usable state again. They need to be self-checking. For most cases, doing manual testing, we are the ones who have to actually verify if the code is working as expected. And from person to person, those expectations might actually change. If you have one person who runs a test and they think, okay, yeah, that functions as I might think, you'd have someone else say, I don't think that works, which is, you're basing it off of someone's decision. Maybe it's a design document, whatever. A unit test is going to tell you exactly how that code functions and how it has been coded to function. And lastly, they need to be timely. And how I define this is unit testing shouldn't take a long time to write each individual test. It's usually like a one-to-one. If you write a unit test, and then the production code should follow shortly thereafter. If you put your head down and you start writing a unit test, and then you look up and you realize that it's taken way too long, The vast majority of that probably comes from the fact that the code that you're trying to test against is probably really hard to test, obviously. And I would take that as a design smell and something that you should actually consider changing your production code to make it more testable. So why are we talking about unit testing? What are some of the benefits of unit testing? First and foremost, it's less time performing manual tests. If you have a suite of tests, you can just hit the play button on your test runner and all of the tests will pass or fail, hopefully not fail, but you shouldn't really have to ever open up the application itself or do anything further than run the test suite. Another part is there's protection against regression. When you introduce a new feature, in a perfect world, we would test all of the previous features, but in large systems, that isn't always feasible. But if you have a suite of tests backing that, it's very easy to make a change to your system, rerun the test, and make sure that you didn't introduce any changes to your code. This is a really cool part of unit testing that you kind of get for free, and I think it's a big part that people might overlook. You get executable documentation. So if you have tests that are named correctly, or in a good way, I like having the unit of work followed by the input and then the expected behavior. If all your tests are named as such, there isn't a question about what that piece of code is doing, because the unit test will tell you exactly what it's doing. There is no Confluence document or anything that says, well, this is how it should work. You're not in a meeting and it's like, I think this is how it works. If you have tests to back it up, they will tell you exactly how it works. And if you were to change behavior, your tests are going to pass or fail, or you have to have new tests. It's a living executable documentation. And then just by nature of putting tests first, your code is going to be less coupled. Generally, when you don't think about tests in your design, you generally introduce a lot of dependencies that you might not be aware of. But putting tests first, you can't do that because the code won't be testable. So to make your code testable, it's going to be less coupled by design. Like anything, there are no silver bullets with developments. There are some drawbacks. This is probably the biggest one that I think people get hung up on, is the fact that it slows initial development velocity. And I bold initial because it's true that if you are writing a feature from scratch, we don't just jump right into a feature. First, you have to start with the test and kind of think about design and how that's going to work in your system. And so your initial development without testing is going to be pretty quick. You can just you pump out features on and on and on. But if you don't have tests backing that, it's going to be a lot harder to develop on later in life. I mean, think now of something like Control Panel. There's really aren't a whole lot of tests behind that, and making one small change is really hard. In a perfect world, if there were a suite of tests against that, we can actually verify that there are no regressions happening, and we can actually put out product a lot faster towards the end. Bad tests can actually diminish value. Just because you're testing doesn't necessarily mean that it's a good thing. Tests are something that you have to maintain. If you, say, for example, are testing a method and you introduce a new signature and you're not using some sort of factory method in your tests, you have to go through and change all of your tests that introduce that new parameter. It can be a huge pain, as well as if your tests are very brittle, because anytime you make some any minor change or even major change to your production code, if all your tests are constantly breaking, people aren't going to really want to keep them up, and it can actually slow down your development time if you have bad tests. And then lastly, it's difficult with legacy code. A big part of test first design is that you're putting tests first, and a lot of old code isn't testable. So trying to put tests against legacy code can be quite difficult. It's a lot easier when the product is in a more greenfield state. So what does a unit test actually look like? This is kind of what I was talking about before, about the well naming. This is how I like to do it. It's a class that is noted with a little button here. Yeah. It's a class that's attributed with the fact attribute. And the first part of it is valid word. That is going to be the unit of work. This is what we're going to be testing against. The second part is like the scenario. That's going to be the input that we're going to be using for that test. And the last part is like the expected behavior. What do we expect to happen when we give it a null input? So in this case, the isValidWord method, when given a null input, should return false. When we actually fill out that method body, it's going to look like this. This is following a very common pattern called a range act assert, where first and foremost, we kind of arrange the test. This is going to be newing up any classes, defining any mocks or anything that we need to actually get the system under test up and running, followed by act, where we actually do the interaction. So here we are calling isValidWord with a null parameter because that's what we expect. And then we're asserting that the value is going to return false, which is the assert phase. This is another really good quote, because I love quotes, by Uncle Bob. The act of writing a unit test is more of an act of design than verification. I feel like a lot of people, they kind of rally around the idea of unit testing because it's great for QA, it reduces bugs, and those are all great things. But a lot of what you do when you're writing with a test-first approach has to do with design. And then you kind of get the regression testing as like an added benefit. And I like to see, kind of describe this as like an inside-out versus outside-in approach. When you're not really considering tests first, you design like the method first. You kind of just, you write a method, maybe no parameters, and you just kind of in the guts of it. You don't really care about how people are going to be calling it quite yet. You're really focused on implementation. Whereas with testing first, the very first thing that you do is call that method. There is no code here because the first thing we do is just write the test. There's no code inside of that isValidWord. We don't really know how the implementation works. We just know that that's how people are going to use our method. So following up to now, test-driven development is, again, it's a design methodology that's just going to leverage unit testing. And it works by the very, very first thing you do is you create a unit test that fails. You don't write any production code until you have some sort of assertion about how you expect this to actually work. Once you have your assertion ready to go, you want to make sure that test passed and only for that test case and nothing more. Once you have like for example, the null case. Once your method handles that null case correctly, you don't add any more code. You don't say, okay, well, I know I also want to do blank strings, and you add that there. You always make the test pass and nothing more. And lastly, you want to make sure that this is your opportunity to do any sort of refactoring. Right now, you have a passing test that verifies your behavior. And so now you have the opportunity to actually refactor without breaking anything further. The other thing is, like, don't worry if it's not perfect. I know like you have a lot of TDD purists who say like you have to do it, create the test, and then make it pass and then refactor. But when you kind of get into it, a lot of assumptions that you can make are going to happen. So don't feel like you're constrained that like, oh, I want to do this, but I can't because I have to go back. As long as you put tests first and you're a little bit pragmatic about it, I think you're going to be fine. So one common thing that might happen when you're doing test-driven development is that you might feel the sense that you are just kind of coding against the tests. So in the case of this, if you have a test case that says, if I have a case that where the random number is 1, return this. If I have a case where it's 2, return this. It's common in like math problems, right? Where it's like, oh, well, the first input is 1, first input is 2, and just always return exactly what the test expects. This isn't very generic. You are coding exactly what the test expects. And again, we want to try to get more generic. So once it's fine to start out like this, but once your tests are actually passing, you actually might want to consider doing a refactoring where something like this, using a container, a dictionary, where there's going to be less cyclomatic complexity because over here we have 3 pass, over here we have 1, and we're not actually coding against the test anymore. It's a very generic approach to the problem. I touch on this briefly just because I feel like a lot of people haven't heard of it. It's kind of theoretical, but it's a way that we can actually make this jump, because a lot of what happens is people kind of don't understand, like, okay, well, how can I make this more generic, or how can I make this better? And I don't like slides with a lot of text, so again, this is it. It's just saying, hey, in our case, hey, if you have a bunch of if statements, the next thing to consider is going from a scalar to an array. That didn't really apply to us. So we have array to container, and a container is just a generic dictionary. Maybe more concrete is when you have like a null value just for a failing test, and then you can go right to a constant, and then a constant to a constant plus. And again, it's just trying to solve this problem, because when a lot of people, when they kind of first start TDD, they have this problem where they'll do the first couple of tests and it's fine. Like, okay, that makes a lot of sense. But then they get to like the third or fourth test and they're like, well, I feel like I have to write the whole program at this point. Like, where is the intermediate step? And again, so that premise is what's supposed to solve that problem. So at this point, probably a lot of glazed looks, a lot of talking. I kind of want to do a demo that kind of contrasts like traditional development and test-driven development, and you can kind of see the spoiler alert, and you can kind of see the difference between the two. So I guess before I get into move over. That is not good. There we go. Before I get into that, does anyone have any questions at this point? Awesome. So again, this is not meant to be a necessarily complex program. I don't really want to make it difficult to understand what we're trying to do. Just kind of how our thought process and how the actual development process changes based on if we have tests first or not. So this program is going to take a file as input. I'm using a file because I find a lot of TDD talks and presentations, they just kind of, it's this perfect world of no dependencies, and that's just not real life. So we're gonna take a file as input. That file is just gonna contain a string, and we need to calculate the cost of like sending that string, as if characters cost money. And there's gonna be some rules around that. So taking a traditional approach, the first thing that we might consider doing is saying, okay, well, I want to be able to calculate the price of this string. So let's go ahead and let's make a new class and not have it in our main method, because we're not heathens. So we create a new price calculator, and we know that the price calculator is going to have to calculate a price. So it's like, okay, let's just call it an int. That's simple enough. Calculate. We're taking this in from a file, so let's go ahead and say, okay, we're going to calculate a price from a file. The file is going to be the input. So let's go ahead and get a path for that. And then I know, okay, so now we have the path. We can say file dot read all text, and then that path. So that should be how we can get text from a file. I'm not really sure if that's going to work. So we can go ahead and we can say, okay, well, let's just do a write line. I don't really care about what the return value is right now. I know I'm going to need to actually call this, and oh well, okay, I need to actually go in here. I need to actually create a file. I don't have one yet, so let's just call it input.txt. Let's go ahead and edit that. And we can just say hello. And we know that that's in demo/input.txt. Save. And then .NET run. Oops. CD, is it traditional? CD traditional. .NET, .NET run. I do have nets. Okay. So at this point, we have a program that takes a file as input and is outputting the results. We can be pretty confident that that is working for us. So, okay, we don't need this anymore. I'm pretty confident that that input is working for us. So one of the first rule is that we're going to put in place is that if the length of the string is greater than or equal to 20, we're going to return 25 because our manager is saying that first and foremost, if a string is going to be greater than or equal to 20, we're going to be nice about it, and we're just going to tell them that, hey, you maybe have some enterprise license, and we're just going to say that's going to be your cost. And so now to verify that, we have to be like, okay, if it's greater than or equal to 20, return 25. So we need to, what, 1, 2, 3, 4, 5, 10, 15, 20. So that should be 20. .NET runs, so we did 20, that should be 25, I believe. Oh yeah, that would probably help if we actually kind of did this. We have the result, and we can just say console.writeLine. Your cost is result. All right, where was that? Was 20 still? I believe I put in a text file, so that should be 25. Okay, cool. So if I were to make that 19, I think that should be 0 at this point. Yeah, okay. So, okay, well, I know that if it's not greater than that, then we just kind of want to return how much this is actually going to cost. We're just going to say input.length. I had 19 in there, I think. Whoa. I had 19 in there, I think, so we're just going to run the same thing, and that should be 19, I believe. Okay, yeah. That's awesome. So I'm pretty sure we have those two pieces of functionality working. The last thing that we want to be able to do is that if it's greater than or equal to 3, so we're going to say like if your message is actually pretty short, we're not really going to care a whole lot. You're a low tier customer, we're just going to say here, it's free trial, if you will. We're going to go in here, we're going to say input length is. We're going to add 5 to it. So some sort of like large message, like tax, if you will. If you have a large enough message, we're gonna charge you extra for it. So let's make sure that works. Length of greater than or equal to 3. So if I do 3 and I hit run, I don't even know. That's 3, 8. Yeah, that makes sense. Okay, so it's gonna be 8. And let's just go ahead and change it to 2 because that's going to be a less than an edge case. And that's going to be 2. Okay, so I'm pretty happy that this is working as I would expect. I don't really want to touch it because that was really tough. I had to think about like a ton of math, and I had to keep modifying this file. So there's some things I want to change to it, but that means I have to go back and test all my other cases. So we're just going to leave that there. So that's kind of, again, how I feel like a lot of traditional development happens. Whereas the key takeaways for that example is I want you to take home with is that we had to run the application a lot. We ran it every single test case where we had to verify that we were getting the input correct. We had to do a lot of mental math to make sure that all of our numbers were correct. I could have been wrong. Could be like, okay, yeah, maybe that's supposed to be 18, and my program tells me 19, and I have to figure out, am I right? Is the program right? And we actually had to use, again, we had to use an actual file. So if we were to do that exact same program again, but we were actually going to take a test first approach to it, this should end up looking a lot different, as well as the approach in development that we're going to take. So if I wanted to write this program, I know that, again, we're doing, the first thing I wanted to do is we're going to need to add a unit test. I'm going to call this just price calculator test, cheating a little bit because we already did it once. And I know that it's going to be called price calculator, but it doesn't have to be. That can stay unit test 1, and you can be kind of unsure about what it's going to be called. Because again, it's about design. So call it unit test 1 and kind of figure out what the name is going to be later. So the first thing that we're going to want to do is write a test case for our program. So I actually have this little handy dandy template where I can say, okay, I want to introduce a new test case, and it already has how I like to name all my tests. So the first thing here for our unit of work is going to be that calculate method. The scenario, for starting off tests, the first thing I like to do is the simplest test case that actually provides value. So in this case, the simplest test case that provides value is going to be an empty string. So we can say like when empty string, and then the expected result in this case is just going to be probably returns 0. And this could be a case where you maybe need to go talk to your product management and be like, hey, we didn't really consider like what happens when they send nothing. Like, should we charge them anyway? Should we return 0? So like already we're making design decisions. Then next we want to go ahead and actually new up that price calculator, because this is going to be our system under test. And again, pure TDD, they might have you go create the class right now. I'm okay with just leaving it just kind of red and just kind of letting the design process kind of work itself out. I've already called it price calculator test, but you could just call this really whatever. You call it new thing, and then just kind of as you write your tests, figure out what you want it to be called, and then create it later, because it's a lot harder to change production code than your test code. So I'm just going to say I'm going to leave it blank for now, and we're going to do var result equals. I want to use that thing, and the system under test is going to be the calculate method. So I know we're going to be taking file as input, but so I would give it a path here. But if I give it a path here, that means I have to use a file. Okay, I'm not really sure how that's going to work right now, so we'll just leave that blank. And I want to assert that the result is going to equal 0. So at this point, we have a failing test. They consider tests that don't compile failing. So we can go and we can go ahead and we can add any of the things that we introduce. So here we introduce the price calculator, which will fix that error up. And we also need to introduce this this calculate method. So at this point, now we have a test that actually should compile, but it's not going to actually pass because we didn't really do anything to it aside from create it. So at this point, we want to make the test pass, and the simplest way to do that, and for our case, is just going to be doing a return 0. Because again, it's all about just making the test pass first and worry about any sort of big leaps later. And then we can kind of take this time to think about, okay, well, that doesn't make any sense for an empty. That's going to be the path most likely. So let's just say, let's change that up. I'm not using any of this stuff, so we can just kind of get rid of that. We can go ahead and we can rerun our test just to make sure. So we have a passing test, and we kind of have to come back to this where it's like, I don't really understand how this is going to work for tests, because it needs to be isolated. I don't want to depend on any sort of file system. So I know if I was doing this a different way, I would probably just do file dot read all text and then path. But I can't do that because I wouldn't be able to actually give any sort of input. So this is kind of one of those first aha moments of, if you take a test first approach, you quickly realize things you can and cannot do. So doing the traditional development, this was fine. We didn't really see a problem with this. Our program worked. But to actually make this testable, we're going to actually have to rethink how we want to write this. And a very common approach for this type of file access is just to use the adapter pattern, wrapper pattern, whatever you want to call it. And so that way we can actually have this calculate method depend on the interface rather than the actual file.readAllText. There's actually a library out there, another one that I work on called system.io.abstractions, that pretty much does exactly what we're going to do here, but at a much more enterprise scale, if you will. So the first thing that we're going to want to do is, in order to wrap this up, we're going to want to add the interface that this file is going to depend on. So let's just call it a file provider, because it's going to give us a file. This interface will only expose one method. It's going to expose the read all text method, and that's going to take a path. And then we can go over here and we can add add another class. We'll call this the actual file provider, and we'll have this class actually inherit from that, and then implement. And we can actually have it implement that method. If I can type. And this method, all it's going to do is return the read all text of that path. So this is what we were using to get the file input. This was var input equals file read all text. Now all we've done is wrap that call in a class called file provider that takes a file provider interface. So now that we have that sort of extraction, we can say, okay, I know how I'm going to handle that. I can go back to my test and be like, okay, yeah, I have this. Now I can do input. So now I need to be able to actually I need to create a seam so that the price calculator can actually use this new interface. So we can say var file provider equals new new mock I file provider. And then for this test case, we want the file provider to, I'll explain all this a little bit. We want this to return a blank string. Make this a bit bigger. All right. So what this is saying is that we have an interface called iFileProvider, and on the interface is a method called read all text. When read all text is called in the context of my test for any input, because all we care about is the path. We don't care what the path is. I want you to return a blank string. So this returns method here is essentially the same thing as changing this text file. Right now, this is a blank text file, if you will. This is a text file that has 3 A's. At this point, we are actually, we are stubbing out the file system, and we are kind of giving it its own its own return value rather than actually depending on a file. So now I need to actually put this file provider into our program. And there's a couple places that I can put this. I can actually put it in the constructor. I can have the calculate method itself call it. And there's pros and cons to both. I'm going to put it in the constructor because I kind of feel that the calculate method is only going to have, it's going to be that public interface. And I know that the class, the price calculator will always use that. If you think that you're going to have multiple calculate methods that might not depend on that interface, then go ahead and throw it in the calculate parameter. So that way you're not actually depending on an interface that some other public interface isn't going to use. So over here, I know that price calculator is going to need to take the file provider in, and we're going to say file provider.object. And I need to be able to introduce that constructor into the class. And this is another reason why I chose this. I mean, this should look very familiar to individuals who have done a lot of UX code. This is just setting up so that when this method or when this class is instantiated, we're going to, it needs to provide a file provider. In order to use this class, it has to have a file provider. It doesn't care where it's coming from. It just knows that it needs to use it. So at this point, we have a price calculator that takes that in, and then our test is going to pass because we're still returning 0. But at this point, it makes a lot more sense because we're actually giving it input. So I think about the next test case where it's like, okay, if it was greater than or equal to 3, then we have to add that tax to it. So that means cases blank, which I already have, 1 and 2 are pretty much all the same thing. So rather than kind of copying this method over and over again and just kind of changing the method signature, we can go up here and we can do what's called a theory. And so a fact is one input and it's one expected result, whereas a theory lets you do multiple inputs in the form of inline data. So if I were to do inline data blank string, turn this into a parameterized test, change so that our return is always returning what we expect the input to be. This setup is pretty much exactly the same case that we had before. But now we can go here and we can say, okay, well, inline data, and like what happens when it's one character. And we expect it to be the length of the string. Okay, so yeah, this is going to actually be calculate when small message returns message size. Sure, that makes sense. So if we run all the tests, it's one test block, but over here we should actually see 2 tests because they are treated as individual tests. And the second one is failing because at this point we're only returning 0 and that's it. We need to be able to handle the case in which it's not just 0. So for that, I know we're going to need to actually get the get the input. So instead of using that dependency on the file system, we're going to use this interface that we plugged in, and we're going to say input equals that. And then this is going to kind of nod to that whole transformation priority premise thing where the smallest thing that we can do is change this from a constant, a 0, and we can say input.length. So that is it's a very small change, and it's going from a constant to a variable. And we can run those tests again, and that should pass. And we know that there's one more case here. Again, I'm saying if it's less than 3, that if it's less than 3, come here, then it should return the message size. And we have 3 passing tests. All right, so the next test case that we had was the case in which it was a larger message, that's going to add some sort of message tags to it. So, okay, we have small message. So like we can say like when large message, and this is going to it needs to add the message. It needs to add the message tags. String input. And for the most part, this is going to be pretty much the same. So we can just we can copy that out. We know that this is going to be another theory because I like doing the edge case and the edge case plus 1. So we're going to say we've gone from A, B. This is going to be A, B, C, and let that fail. What I do? Oh yeah. Pair programming. Okay, so input and then returns input, calculates. This is going to be that same. Oh yeah, right. I meant to do this. Sorry. So it's a blank string. Calculate is actually taking in a path, and this is kind of again this where it's like it's not technically any different, but it's intent behind your code. So I have a blank string here when really I like using isAny and just saying I don't really care what string you use. It doesn't matter to me, and that's why even like looking at this, that was kind of confusing me. Like, why is there a blank string there? Because in the context of our test, we just don't really care. It has no impact on what we're trying to do. So, okay, so we have this is going to add some sort of message tags. I defined it as just 5. So we're going to say here plus 5. Now I don't necessarily like doing this because it's wrong in a couple ways. Plus 5 to me is kind of magical. I don't really know what it means. You might be able to say, okay, well, I can kind of infer that we're adding a message tag. We have an add here, and that's a 5. So, okay. Then there's also the concept of, well, what if we were to actually change that number in our production code? We'd also have to change it here. And this just kind of makes our test a lot more brittle than it needs to be. It's like, okay, well, there's going to be this thing called a tax. So, all right, let's just, what if I just did like price calculator dot message tax, and that's not going to compile. So we can come over here and we can add it. And we're going to say that's going to be 5 for our purposes. Run our tests. And this should give us a failing test because we don't support the adding 5 yet in our code. So okay, we need to be able to support when it's a large message. So we can say if input.length is greater than or equal to 3. Let's go ahead and return input.length plus 5. That pretty simple, pretty elegant, pretty straightforward. Not so elegant, actually. We're going to fix that in a little bit. So boom. So now we have another test case passing, ready to go. At this point, we can actually do some refactoring because again, we have tests backing it, and we shouldn't really care so much about breaking things because these tests will tell us whether or not we change any behavior. So one thing that I notice about this method is that I feel like it's doing a lot of things right now. It's violating single responsibility. And it's like, well, how is that possible? There's like 4 lines here. But with the calculate method, it has to know what is a large message. It has to know what to do when that message is large. And then it also has to know how to calculate a small message. In this case, it's just returning input.length. So what I like to do in these cases, it's a lot of magic numbers. I just like to put intent around a lot of them. So we can do something called just extracting a method. So we can say, kind of just reads like an English statement. We can say, if message is large for that input, and then we can go here and we can refactor this one as well. We can just call this one like handle large message. And then this one is just going to be our small method. So we can say handle small message. And so now this calculate method really only has one responsibility. It just has to know the algorithm of how to actually do the calculation, but not the implementation details of everything. All the implementation details are kind of wrapped in these private methods that actually hold the implementation. And we're only testing against the public interface, so we're not going to be writing tests for these. We want to make sure that our algorithm holds true. So this is, if I run the test one more time. So that was a pretty large refactoring, and all of our tests should still pass, which they do. So the very last test case that I wanted to introduce is something called a property test. If you're not familiar with a property test, it's essentially kind of how it sounds. It's making sure that your test cases fulfill a property rather than worrying about what the actual input is. And I'm going to kind of demonstrate how that's going to work. So we had in our previous requirements that if a message is if the message size is greater than or equal to 20, we're going to cap it out at 25. So that's a property. The cost of our messages can never exceed 25. So when message exceeds, sure, maximum size returns maximum cost. And that's going to be an input. And we can go ahead and we can decorate this with property. And kind of taking this again, and kind of a nod to bad tests, and tests are something that you need to be maintaining. You can kind of see here we have like a lot of duplication here. I would probably go ahead and actually like move this into like some method that just says create file, create price calculator with return, and it's going to have some sort of exact input that you give it, so we don't have all this duplication. But to move on with property, we want to make sure that we want to assert that the result here is always less than or equal to 25. For this case, we're actually going to say that this is going to be a non-null string. Okay, so now this is a test that should fail because it's possible right now that that our calculation method can actually return higher than 25. Because if we gave it a string that was incredibly large, it's just going to return large plus 5 or whatever our tax was. But if you notice, we didn't give it any values. We didn't have some sort of edge case of like A through Y or whatever for 25 and see if it actually works. This was just a way to actually just assert that this property that we have is actually functioning as we expect, which I always thought was pretty neat. And then just so to implement this, we can just say if input.length is greater than or equal to 20, return 25. And that should hopefully pass. Cool. And then in the instant of time, and then same thing here. I would refactor this out to a method. This just become a const saying this is like maximum cost, and this would just be is has message exceeded some threshold. So that's pretty much the program. Again, it should be written a lot differently. It's testable without having any sort of file access. And kind of like the big reveal that I really like to show is the fact that the program is empty. We wrote a program and we didn't even touch the main method at all. But so in order to actually use it, it kind of just boils down to wiring it up at this point. So we can say new price calculator. I know we had to give it a file provider, so we're injecting that dependency in there. That was weird. The result is going to be price calculator dot calculate. Kind of the same thing here, where we have demo input.txt, console dot write line. Result is sure. And let's make sure this is, I forget what we set this to. So now that we're actually running the application, let's just say that it's, I don't know, 2. And hopefully this says 2. So the big takeaways here is we didn't touch the main method at all. We didn't have to touch this file at all until we're actually using the application. And we didn't actually have to run the application at all. All of our logic, all of our design, all of our thought process was done right there in the IDE. So that was hopefully. Oh, I didn't hit the F5 button. What is that, Shift F5? No. Promise I sort of know what I'm doing. Why can't I click on? Okay, this will be fun. So hopefully that is something. Oh, we're so close. Something cool. So another quote that I love, "New is glue" by Steve Smith. And this is essentially saying that anytime that you use a static reference or the new operator, you are tightly coupling yourself to that implementation. So you'll kind of, I won't go back to it, but you notice that in our the traditional approach, we had that static method, we had the static file actually in the implementation, and that means that method can only use file. Whereas in the TDD approach, we moved it up into the main program, and we used the new operator there. So we bubbled up that dependency to the very top, and we made all of our other code very loosely coupled and didn't use the new operator until we actually have to. It's not like the new operator is bad. It's a design decision. Just be conscientious that when you use it, you are locking yourself into that dependency. So one last kind of example that I wanted to give, I actually ran into this probably 2 or 3 months now. This actually happened here at Plex. So I was running into the problem for Active Directory that the first user in a brand new PCN didn't work. And so that was like, I was thinking about how you would actually try to replicate that. And it wasn't fun. First and foremost, there aren't many PCNs that have no users in them. So you had to open the Plex application, you had to find a PCN, hopefully one existed. If not, you had to create one. And once you created it, you had to do PCN copy and you had to set it up and then you had to log into it. So it was this huge setup process just to get a blank PCN, just to be able to replicate this one time. And if you're not able to reproduce it that one time, you have to set it up again. So rather than setting up a new PCN over and over and over and over again, really what's happening is Plex is just calling this code. And when you're clicking around the application, it's a long way of saying, hey, like create this organizational unit, which was kind of the crux of the problem. So rather than go through and actually even have to open Plex, you can write a test. And this is actually calling the method that was having problems. And right now, the test is passing, because hopefully. But I guess first and foremost, this isn't a unit test technically, it's an integration test because it's actually talking to DevAD. And that's why we kind of have this bottom thing here. This is like teardown to make sure that we clean it up. The first three parts are still your arrange, act, and asserts. But what we can do is we can say, okay, well, now that I know that it was failing, I can go over here and I can actually just change the production code, and I can run the test. I can run the test again. And every time I do a test run here, that's creating a new user in a blank PCN. And it fails because I'm checking a property of Ember, which doesn't exist. So each test run here, is saving 10, 15, 20, however many minutes you think it would take to create a new PCN, create a user, get it all set up, log in, et cetera, et cetera. It's just not going to work again, is it? Yeah, I can't like slide down. Well, I just want to scroll though. I mean, well, it won't let, but I'm just like I don't want to even edit it. I just want to scroll. It's just weird. It doesn't make any sense. So hopefully that wasn't bad. Pretty sweet. And long and short of it, unit testing is awesome. I think we should do more of it. I try to use it as much as possible. If you want to get involved as well in terms of practicing or just involving, contributing to the project, Exercism is a great website that has like 50+ languages where it will actually give you a problem and you have to solve it using a TDD approach. And there's, each language has upwards of like 100 problems. All the problems are, we have tracks. So each problem is defined, but they're not implemented aside from who actually contributes from the community. So for example, we have like 112 problems for the C# track, but like Pony, which is apparently a language, has like 12. So if you want to contribute, if you want to learn more about TDD, I recommend trying out Exercism. Aside from that, I'm out. So that is all I had.